We will solve problem 2.26 from the book Heat Transfer J.P.Holman 10th edition. Here the statement of the problem: a hot steam pipe having inside surface temperatures of 250 centigrade has an inside diameters of 8 centimeter and a wall thickness of 5.5 millimeter. It is covered with a 9 centimeter layer of insulation having thermal conductivity 0.5 watt per meter dot centigrade, followed by a 4 centimeter layer of insulations having thermal conductivity 0.25 watt per meter centigrade. The outside temperature of the insulation is 20 centigrade. Calculate the heat loss per meter of length. Assume K of the pipe is 47 watt per meter dot centigrade. Okay, so the inside surface temperatures of the pipe, that is Ti, and it is 250 centigrade, and the inside diameters, that is 8 centimeter. So inside dia, that is 8 centimeter. So inside radius will be di divided by 2, so you will get that is 4 centimeter. Convert that into meters, just divide with 100, we'll get into meters, so it will be 0.04 meter. Okay, the wall thickness of the pipe is 5.5 millimeter. So wall thickness of the pipe is xt, and that is 5.5 millimeter. So I can say 5.5 multiplied by 10 to the power minus 3, or 0.0055 meter is the thickness of the pipe wall. It is covered with a 9 centimeter layer of insulations. So then the pipe is covered with the 9 centimeter layer of insulations, and this is X1, the insulation, first insulation that is covered the pipe, that is 9 centimeter, so 0.09 meter, and its thermal conductivity X1, that is 0.5 watt per meter centigrade. Then the first insulation is followed by second insulations, and its thickness is X2, and that is 4 centimeters. It means divided with 100, convert into meters, 0.04 meter. And its thermal conductivity of the second insulation is K2, that is 0.25 watt per meter centigrade. Outside temperature of the insulation is 20 centigrade. So the outside temperatures P naught of the insulation layer 2 is 20 centigrade. And thermal conductivity of the pipe is K, that is 47 watt per meter dot centigrade. And we need to find the heat loss per meter length. So heat loss per unit length is our concern to find of this pipe. So it's a composite valve pipe. So let's say this is the pipe, and this is the valve of the pipe. Its internal radius is Ri, and the thickness of the pipe is Xt. This is Xt. Now this, so a first layer of insulation is provided over this pipe, and then the thickness of the second insulation is, let's say, that is x2. So I hope you understand how many insulation layer is provided over this pipe. So this is the pipe, and this white diameters is basically represent the pipe thickness. So this is the pipe thickness, and this is the internal radius of the pipe. And then the first insulation is provided over the pipe, and then second insulation is provided over the pipe, and its thickness, second insulation is x2, and for the first insulation is x1. Okay. So if you consider, look at this point, this is Ri, internal radius of the pipe, and this is the half of the internal dia. Then the outer radius of the pipe is, let's say, R0. So this R0 will be equal to Ri plus thickness of the pipe, and this thickness of the pipe is Xt, and Xt is nothing but it is, yes, it is 5.5 millimeters. So Ri is 0.04 plus Xt 0.0055. So after adding, you will get the R0 of the pipe, and that is 0.055 meter. Now we are interested to find the radius of the first insulations. This is R1. So it will be equal to the sum of the R0 value. So then it is R0, and then this thickness. So this thickness, that is x1. So I can say that R1 is equal to R0 plus x1, thickness of the first insulation. So R0 is 0.0455 plus x1, that is 0.09. So after adding, you will get its value, that is 0.1355 meter. Now we are interested to find the outer dia, that is R2. So it will be the sum of this R1 and the insulation, extra insulation of the second layer. So I can say that R2 is equal to R1 plus X2. And what is R2? That is 0.1355 plus X2, that is 0.04. After adding, you will get its value, that is 0.1755 meter. So all the radii we have calculated so far. So things are very easy now in order to solve this heat transfer per unit length of the pipe. Now look at the resistance network diagram. Inside this pipe, the temperatures are starting from this point. Here the temperature is Ti. It is Ti. So the first heat transfer, that is conduction heat transfer, occurs within the wall of the pipe. So it will be, resistance will offer to the heat transfer by the pipe wall. Then second, heat transfer occur offered by the, then heat transfer will occur through the first layer of the insulation. So obviously it will offer the resistance to the heat transfer. And then the second layer of the insulations, and then finally here the outlet temperatures. At the surface of the outlet temperatures you will got, that is T0. So this temperatures, so this resistance that is offered to the heat transfer by the wall of the pipe, that is R, this is R1 first layer of insulation, this is R2 second layer of insulation, or we can also say RW. So the resistance that is offered by a wall of the pipe, so this is RW. This is RW, and the resistance, the heat transfer is in the cylindrical coordinate. So the resistance will be equal to ln R0 divided by Ri divided by 2 pi A of the pipe. Then R1, here the resistance will be equal to ln R1 divided by R0 divided by 2 pi A1. Here this is the second resistance offered by the second layer of insulations. There is ln R2 divided by R1 divided by 2 pi A2. A2 means thermal conductivity of this second layer of insulation. So this RW is equal to ln R0 divided by Ri divided by 2 pi A. So ln, what is R0? That is 0.0455 divided by Ri, that is 0.04, 2 pi to K is 47. After simplifications you will get the RW, and that is 4.362 multiplied by 10 to the power minus 3. Now resistance R1 is offered by first layer of insulation. This is ln R1 divided by R0 divided by 2 pi K1. So this ln, what is R1? That is 0.1355 divided by 0.055 divided by 2 pi K1. K1 is 0.5. So after simplifications you will get R1 value, that is 0.3474. Now the resistance R2 offered by second layer of insulation, it is ln R2 divided by R1, and this is divided by 2 pi K2. So what is ln R2? R2 is calculated, that is 0.1755 divided by 0.1355 divided by 2 pi multiplied by K2, that is 0.25. After simplifications, you will find its R2, that is 0.8246. Okay, so the total resistance that is offered by the pipe valve, that is R1, that is plus R2. So you will get this first answer is, so RW is 0.00462, then R1 is 0.3474, then plus R2, that is 0.8246. So after adding, you will get the total resistance, that is 1.172. The heat transfer per unit length is equal to temperature difference divided by in between, so the total resistance, and that is RE, that has been calculated. So the temperature difference is Ti minus T naught divided by RE. So the heat transfer per unit length, what is Ti minus T naught? And that is 250 minus 20 divided by 1.172 divided, you will get the answer, that is 196.2. That is our final answer. This is the heat loss per unit length of this composite pipe. I hope you understand. If you still have any confusion, you can ask. Thank you so much.